All right, it's recording. Eyes and ears towards the board. Listening. All right, so let's fill in some notes here for you. The fundamental theorem of arithmetic states that every whole number greater than 1 can be written as a product. Now, what does product mean again? Hands up. Hands up. No one knows. Well, let's go with Zara because I think you mouthed it. What was it? What's a product mean? Oh, it wasn't you? Sorry. Was it Ex1D? What was it? Good. Product means multiplication. So if you didn't know that, that's the term that we use. Addition is sum. Subtraction is difference. Okay, so when we say product, it means multiplication. So what are they trying to say? They're saying that any number that is bigger than 1, you can actually rewrite it as the multiplication of, fill this in, prime numbers. Now you've already learned from last session what a prime number is. We have a chart for you. So exercise 1C, I gave you the notes, the chart, prime numbers chart. So what does that mean? Let's take an example. See number 6. 6 is bigger than 1. They're saying that every number that's bigger than 1 can be broken down into prime numbers, but they're multiplication of prime numbers. So here's an example. 6, if we think about it, I wrote 2 there, but 2 times what will give you 6? Can I please have, let's go with Yi Chen. 2 times what will give you 6? 3. And you can see here, 2 and 3, they're both prime numbers. 2 has only a factor of 1 and itself, so it's a prime. 3 has only a factor of 1 and itself, so it's a prime. So 6 can be broken up into 2 times 3. Let's test a bigger number. Let's say 20. The technique that you're seeing that I'm using over here, this is called a factor tree. If you're wondering what I'm doing there, this is called a factor tree, which I'll show you in the next few examples why it's useful. So let's do a factor tree for 20 as well. So I'm going to write 20 on the side. Think of 2 numbers that multiply to give you 20. Give me 2 numbers that multiply to give you 20. Let's go, Zara. 5 times 4. So you got 5 times 4. Now out of these 2 numbers, which one is a prime? Let's go, Willow. Which one is a prime? 4 is not a prime because it has factors of 1, 2, and 4. We just need 1 and itself. So it must be 5. And why is it 5? Because the factors of 5 is only 1 and itself. That's what a prime is. Whereas 4 has factors of 1, 2, and 4. That's too many. So that now becomes a composite. So 5 is a prime, but 4 is not. So what we do is we can break, Xavier, we can break the non-prime, which is a composite number. We can break it further. So let's break it further. 2, if I break it down, what 2 numbers multiply to give you 4? 2 and 2. And those 2 are prime numbers. 2 is a prime number. So now I have 20 is equivalent to 5, which is a prime number, times 2 times 2. Because 2 times 2 is 4. And then take that number times 5 should give you 20. So we can break it apart and say 20 is actually the same thing as saying 2 times 2 times 5, because that's your prime numbers. And that's what that statement's trying to say. The statement's trying to say that any number that you can think of that's bigger than 1 can be broken down into their prime factors, okay, because these are all factors. They can be broken down into their prime factors that are products of each other. Okay, now that's going to be key because let's think about this again. Yesterday we learned about squares and cubes. Now 2 times 2, I can rewrite that as 2 to the power of 2 times 5. Now this is what you'll be using to do LCMs and HCF in a quicker method. I'm going to show you in the last example later. Okay, so just knowing how to change this 2 times 2, we can write as 2 squared. Okay, now let's have a look at some of the notes. These notes here is what you might have learned from primary school that teachers might have mentioned. I just thought I'd put a chart there in case you want to refer to it. Things like, how do you know if something's going to be divisible by 10? How do you know that? What do you look for? Is 251 divisible by 10? No, so you're looking at something. What are you looking for? Very good. So that's one of the facts that you can see here. For it to be divisible by 10, the last digit has to be 0. So there's 2, 3, 4, 5, 6, 8, 9. These are common facts that you might like to know. might help you just to find divisibility. If not, you can move on. Okay, so I just thought I'd leave that chart there to help you for some of the ones that you might not know yet. So 5, 10s are easy, 2s is easy. 3, I don't think a lot of students know. So 3, if you add all the digits together and it's divisible by 3, then that will be divisible by 3. Okay? All right, let's have a look at this one. This is what I want to teach you today. So exercise 1D, one of the tricky questions I put in your progress task last term was based on this fact here. Okay, so let's fill it in. LCM is the lowest common multiple, LCM, of two numbers in their prime factor form is the product of all the different primes raised to their highest, fill this in, power. Okay, sounds very mumble jumble. I'll explain what I'm trying to say there, okay? HCF, what do you fill in here? I want you to fill in, it is the common product of all the common primes raised to their smallest power. So here's the technique. If you want to find the lowest common multiple and highest common factor of two numbers, it's really easy when it's small. It's much harder when the numbers are much bigger. So one of the techniques that we can use is called using a prime factor tree. And so how does this work? I'll show you. You do a prime factor tree for 12. So let's do 12. Let's break it down. Give me two numbers that multiply to give you 12. Let's go with Ollie. What two numbers multiply to give you 12? Any two. 6 and 2. Very good. So I got 6 and 2. Out of those two numbers, only one number at the moment is prime. Which number is prime, Gypsy? 2. So 2 is a prime. You don't do anything with it. 6 is not a prime. So you split it up even further. Xavier, give me two numbers that multiply to give you 6. 3 and 2. So you got 2 and 3, and they're both prime. This is called a prime factor tree. So when they say write it in their prime factor form, you can write it as 12 is equivalent to saying 2 times 2 times 3. This is a prime factor form. Okay? Then 6. Let's do the same thing. So I'm going to write on the side here. 6. Break it down. What two numbers multiply to give you 6? Let's go with Aqualia. 3 and 2. So 3 and 2. And again, these two are prime numbers. So that means you can rewrite 6 as 2 times 3. Now let's read the statement. How does this help us? So we've got them in our prime factor form. They're saying if you want to find your LCMs, all you have to do is find the product of all the different primes. So what different primes do I have? I've got a 2 and a 3. Those are my two different primes. But I want to multiply only the ones raised to their highest power. At the moment, if you have a look at this 12, we know that 2 times 2 can be written as 2 to the power of 2. So the highest power there is 2. Whereas this is times 3. Versus over here, this 2, what power is this 2 currently? What power is on top? Even though I don't write it, what number should be at the front here? What's the power? 1. So this is actually saying I've got 2 to the power of 1 times 3 to the power of 1. So if you want to find your LCM, this is what they're saying. LCMs, your lowest common multiple, is multiplying the different prime factors. So we've got 2 and we've got a 3. And you only multiply by the highest power. So what's the highest power for the 2s at the moment? What's the highest power you can see for the 2s? It's 8. Just in case you're not sure. Highest power, this is power 2. Power 1, which one's bigger? 2. So hence, if you wrote 2 squared, that's the highest power of the prime. And 3, well, both of them have a 1. They both have a power of 1. So 2 to the power of 2 times 3 to the power of 1 will give you LCM. So it doesn't matter how big the number is. I can make it 258. And I ask you 258 and 67. If I ask you what's LCMs of that, you don't have to write the multiples out until you figure out what's the highest common multiple. You can actually just break this down using a factor tree, use that as a factor tree, and you'll be able to find by doing that. Okay, so 2 squared is 4. 4 times 3. 12 is the lowest common multiple of 12 and 6. Okay, so that's what they're trying to say in this step here. They're trying to say multiplied the prime numbers, but they have to be different primes, but those prime numbers have to have the highest power, okay, of the list. Whereas in highest common factor, it's the other way around. Because remember, factor and multiples, they're opposites of each other. So if one is the highest, then this one will be the smallest power. So same theory. If you want to find your highest common factor, it is the multiplication of your prime factors, but with the smallest power. So your prime factors at the moment, you know, is 2 times 3, because that's what you figured out over here. The only difference is instead of having the highest power, you're now choosing the smallest power. And out of these two, 2 and 1, clearly 1 is the smaller power. So it must be 2 to the power of 1. And this one, this is 3 to the power of 1, that's 3 to the power of 1. So that must be the smallest power. So what's your highest common factor? 2 to the power of 1 times 3 to the power of 1 is 6. So if you had to work out what is the highest common factor of 12 and 6, the answer is 6. What's the lowest common multiple of 12 and 6? It is 12. Okay, so this technique may feel very uncomfortable. And like I said, out of my 2 classes, there was only 1 student who used this technique for one of their progress task questions. Most other students did the multiples method. So what you learned in exercise 1C, most of you listed out your multiples and then found what's common. The quickest way is this one. Okay, so the last example allows you to give you a practice to do that. So if you have a look here, 63 and 27, you can sit there and write multiples of 63 and multiples of 27, or you can use the technique I just taught you, and you should be able to find LCM and HCF. Okay, now before we do, let's practice using a factor tree first. Okay, so you got to get used to doing factor trees. So turn over the page, go to example 1. Here we go. List all the factors of 15. So how do you list the factors of 15? You must know your times table. So what numbers fit into 15? Give me one, Fitzroy. 5 is a factor of 15. Give me another one. Yes, Eknor. 1 fits into 15. 15 divided by 1 works. Hamza, give me another one. What number fits into 15? No, 10 doesn't fit in 15. So you want 15 divided by something that will give you 0 remainder. So it fits nicely. 15, because 15 divided by 15, 15 fits into 15 once. Okay, so 15 is definitely a factor. Give me another one. Let's go with, when I picked in the back, let's go with Adele. Give me another factor. I'm missing one last one. 3, very good. And the tip here for those who aren't really strong with their factors, you just think of numbers that multiply to give you 15. See, 3 times 5 gives you 15, and 1 times 15 gives you 15. So as long as you know your times tables, that's how you can find out your factors. So you got to pair them. Okay, they always come in pairs. Let's do the same thing. Pairs of factors of 84. Think of numbers that multiply to give you 84. Let's go. Give me the most obvious number at the moment. 84 is an even number, so a factor must be 2. But 2 times what? 2 times what will give you 84? Double of what? 42. So I know that 42 is a factor. Can you see what I'm doing? I'm just finding numbers that multiply to give you 84. Give me another one. Most obvious is 1. 1 times what will give you 84? 84. So hence, 84 is also a factor. Now in between, you're just going to have to figure out, go through your times tables here. So what's another factor you think would work? 21. Very good. So 21 times what will give you 84? Because it has to be paired with something. Also, 4. 4, very good. 4 fits into 84 because it makes sense. 4 goes into 8 twice. 4 goes into 4 once. So 4 and 21 works. Now, to work out the other factors, you can use the divisibility test that I gave to you on your sheet. If you want to know if it's divisible by 3, what do? What did I say on the sheet? Look at the sheet again. If you add them, so 8 plus 4, what does 8 plus 4 give you? 12. Is 12 divisible by 3? Yes, so that means 3 should fit in 84. So let's test it. 3 goes in 84. 3 goes in 8 twice. Remainder 2. 3 goes in 24. Yes, it is. See, that's why that divisibility test is nice to know. So if you want to know if it fits into 3, multiples of 3, add the digits. If they are still divisible by 3, then it works. Okay, so you got factors 3 and 28. We've done 4. Does it fit in 5s? Do you think 85 would fit with 84? No, so we're skipping 5s. What about 6? Look at the divisibility test. Oh, let's test it. 6 into 84. 6 goes into 8 how many times? Once, remainder 2, and then 6 goes into 24. 4, so that means 6 and 14 are factors of 84. What about 7? Do you think 7 would work? No, 7's not going to work. Wait. No, 7 does work actually. 7 goes into 8 once, remainder 1. 7 goes to 14 twice, so that means 7 times 12 gives you 84. What about 8? Does 8 fit into 84? No, because we know 8 times 10 is already 80, and then 8 times 11 is 88. It can't be 84. So 8 definitely doesn't work. What about 9? No. Because 9 times 9 is 81 already, so it can't actually get you 84. So 9 doesn't work. What about 10? No. We're pretty much done. And that gives you all the factors. But can you see what I'm doing? I actually didn't know what worked, but I used the divisibility test and I went through the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can then figure out all the factors. Now, obviously, most of your questions won't be that big, but at least it gives you an edge on how to figure out the factors. Let's go to the next one, factor tree. So this is the skill that you need to learn for exercise 1D to do what I was trying to teach you. Factor tree means to break it up. Now, the nice thing is you can pick any 2 numbers. Doesn't actually matter. Give me the 2 most obvious numbers that you can think of times to each other to give you 140. 70 times 2. That's right. Double of 70 gives you 140. 2 is a prime number. So that's okay, but 70 is not. Break it down further. Give me 2 numbers that multiply to give you 70. Ignore. 35 and 2. 2 is a prime again. But 35 is not. Let's break it up further. Give me 2 numbers that multiply to give you 35. Let's go with Gypsy. 7 and 5. And 7 and 5 are prime numbers. So what does that mean? That means if you multiplied 7 times 5 times 2 times 2, that should give you 140. But remember, we want to write them with the highest powers. If you see anything that you can simplify, notice the 2 times 2. How can you rewrite 2 times 2? 2 squared. Very good. So that becomes 7 times 5 times 2 squared. Now that is the technique that you'll need in order to do the next question. So I'm going to stop the video there. And I want you to try the next question. See if you can find LCM, HCF using the technique that I just taught you up here. You're trying to find the highest power for LCM and you're trying to find the lowest power for HCF. You should be able to do it even if the numbers are really big. So start off by breaking 63 and 27. So find some space. Break up 63. Break up 27. I want you to break them up into their prime factor form. You can break them up into the prime factor form. You can then figure out LCM, HCF. I'll give you, let's go 5 minutes. 5 minutes, team. Let's see if you can figure out LCM, HCF without doing the multiples of the long method. So start off by breaking up 63 and 27. Use a factor tree. Think of any 2 numbers. Any 2 numbers. If you did it correctly, LCM, the notes I told you up here, I said you want to find the highest power. So that means out of the 2, 3 squared versus 3 cubed, which one has a higher power? Clearly cubed. So it should be 3 cubed times, and now 7. This one has a 7. It's a 7 to the power of 1, and this doesn't have a 7. So the highest power that you got is 7 to the power of 1. So if you want to work out your LCM, it literally is 3 cubed times 7, which is, I don't know what that is. That's 27 times 7. 189. So 189 should be your lowest common multiple. And then on this one, if you want to know the highest common factor, it's the other way around. You look for the smallest power. So out of the 3s, look at the 3s again. Which one has a smaller power? It was a 3 squared. So this should be a squared. And out of the 7s, the smallest one is also a 1 as well. So the answer must be Highest common factor is 3 squared, which is 9. 9 times 7, 63. That's your highest common factor. So this is what they're trying to say. One has the highest power, one has the smallest power. It is the quickest way to find LCM HCF. Okay? All right, team, you got about 20 minutes like I promised. That is your time. You either work on exercise 1C or you can start on 1D to practice that skill if you like. I'm only looking for 1C by next week. All right, I'm going to stop the video.